Okay, so I have a question here. How are you getting the a equals x or y numbers? I don't get that part, and would you help me? It would help if I go through it. Yeah, to be honest, I remember doing this, and I personally myself I found your quite difficult too. Um, so yeah, totally understandable. Let's take the first one as an example. So let's have a look here. I'll just copy this first one here. Okay. So okay, so the issue isn't really finding the derivative, because here if you say y equals x squared plus 3x plus 2, the derivative is dy dx equals 2x plus 3. Um, and so dx dy would be 1 over 2x plus 3. That's the inverse function, but with the wrong variable. So let me show you what I mean. Um, so suppose I have the function f of x equals x squared plus 3x plus 2. I can change that into y equals x squared plus 3x plus 2. So that's y equals, and I can complete the square here. So that's x plus 3 over 2 squared. So that's x squared plus 3x. And then let me see what goes at the back. I think it's minus 1 over 4. Let me check that. 9 over 4 minus 1 over 4 is 2. Yeah. Now, if you're not sure what I did, what I suggest you can do is just Google or search in YouTube uh, the process of completing the square. That's the process I did. The reason I did that is so that I can rearrange it as y plus a quarter equals x plus 3 over 2 squared. So square root y plus a quarter equals x plus 3 over 2. So that means x equals minus 3 over 2 plus root y plus a quarter. But there could be a plus or minus issue here. However, they tell us that x must be bigger than or equal to minus 3 over 2. So we have to take the plus answer here, because otherwise, if we took the negative one, that'd be a problem. And now, at this point, you could calculate the derivative, dx dy, because what we've just found, this is the inverse function. So this would be the derivative of the inverse function. Derivative. So I'll put a little dash here. But you see, we don't do it this way because this here is quite difficult to differentiate. It's much easier to do it this way. But here's the complication. Previously, this was an x. And on the next line, the answer, it's still an x. Whereas really the variable should be a y, not an x. So this is kind of the wrong thing. It's the wrong variable. So we need to correct for that. We can see for this question the variable a equals 2. That's what's supposed to go in here. So that means the y is like a 2. But what x value would we use to correspond with that y equals 2? Well, we could get that from looking at this. So if we had 2 equals x squared plus 3x plus 2, those cancel, and I can see that x equals 0, because I'll end up with the equation x times x plus 3 equals 0. So I get x equals 0 or minus 3. But the x is supposed to be more than or equal to minus 3 over 2, so it can't be that. So it has to be 0. So that would be 1 over 3, I think. Now, let's see what I did here. Yeah, yeah. So I did put in the 0. Yeah. So that's how I think about it now. So now that I kind of explained it like that, I'm feeling pretty happy with my choice of 0 here. Yeah, so basically this is like the y, because the argument for this should be like a y value, not an x value. And so when you do this flippy trick here, to find the inverse, the derivative of the inverse quicker, the price you pay is you have the wrong variable in the answer. So you'll have to go from a y to an x, which you can do just by using the definition here. So yeah, and I got 1 over 3. Yeah, so I hope that helps.